Hello there, you are welcome once again to your favorite mathematics YouTube channel, Mathematics by Abu Zainab, a channel specially created for you and I to demystify mathematics and tackle the age-long phobia associated with this subject, one topic at a time. Today, we are looking at a very, very important topic that cuts across several other topics in mathematics, a topic which, when understood, is going to influence your understanding of other topics, and that's no other topic than indices. Indices is actually a plural of the word index. So let's dive in today and learn what the topic is all about. Indices is just a plural of the word index. So what does index mean? To start with, index is a synonym for degree, exponent, or power. But simply put, it's better understood if it's written in mathematical terms. Thus, you have 2y cubed. If you have the term 2y to the power of 3, this 2 is the coefficient, and this y is the variable, whereas the 3 is the index, from where we get the plural indices. Now, there are other names or synonyms for index, and they are exponent, degree, or more popularly called power. They all mean the same thing. So, when we are dealing with indices, we actually are talking about variables that are powers. To start with, what exactly is the meaning of this to a layman? Index, by definition, is the number of times a variable is multiplied by itself. The number of times a variable is multiplied by itself. So, for example, when we say y cubed means we are multiplying y by itself in 3 places. So, y times y times y, that's y cubed. If you now say 2y cubed, it means we have y cubed plus another y cubed. So this is y cubed here, and another y cubed here. So y cubed plus y cubed gives you 2y cubed. So this is the breakdown of what this term means, 2y cubed. Essentially, the power or the degree or the exponent or the index here is 3. The coefficient is 2, and the variable in question is y. That's just the basic introduction of what indices stands for. Let's now go straight to the next point, which is the law of indices. The laws of indices are a set of about 7 rules that guide the operations of indices. And it goes thus. 1. Y to the power of m times y to the power of n equals y to the power of m plus n. 2. Y to the power of m divided by y to the power of n equals y to the power of m minus n. These rules are valid as long as the basis of variables are the same. In other words, if you have multiplication, it simply translates to adding the indices. And if you have division, it means subtracting the powers or indices. So 3, y to the power of m, then n. This is quite different from this. This is single y to the power of m, then in brackets or parentheses, power n. This simply means y to the power of m times n. So please don't mistake this 3 for the 1. Then 4, you have y to the power of 0 is 1, which you can recall from our basis that any value to the power of 0 is always 1. Then 5th, here you have y to the power of minus m equals, once you have negative index, it's meaning reciprocal, y to the power of m. Similarly, if this had been positive and we are desirable of writing in this form, we're going to have a negative here, vice versa. Then 6, y to the power of 1 over n. This means the nth root of y. And lastly, y to the power of m over n. This means the nth root of y to the power of m. These are the laws of indices. And you have to keep them handy at any point in time because you are having some questions that require you using a combination of two or more of these particular laws or rules to solve questions. So let's dive right in and take our very few examples, bearing in mind these laws of indices. So examples. So let's simplify. So we have 3p squared times 4p6 divided by 2p4. Then 2, we have 6m squared n times 4m cubed n squared in bracket which power 2. And then 3, we have minus 2k m squared to the power of 3 times minus 4 k squared, rather minus k squared m cubed to the power of 2. Okay, so let's try to apply the laws of indices basically using these first three examples. For the first example, we have 3p squared times 4p6 divided by 2p4. Now let's deal with the numbers first. That's the rule. The numbers first. The numbers are, that's the coefficients. I mean, we've got 3, 4, and then 2. So to start with, I'm going to have 3 times 4, then divided by 2. The coefficients first. 3 times 4, then divided by 2. Then the letters, we have p squared times p6 divided by p4. First the coefficients, then the letters. So 3 times 4 is 12 over 2 is 6. So the whole numbers reduce to just 6. Then p, as we can see, we have p all through, the same letter. Then we can apply the law of indices. Remember I said that you can apply the law of indices if the variables are the same all through, really. So we have here p. Now we have power 2 times p power 6. The times translates to addition. And for the same p, division translates to minus. So we're going to have times becoming plus, divide becomes minus. Hence, this reduces to 6p. 2 plus 6 is 8 minus 4, 4. And that's the answer to that question number 1, which I believe is quite clear. If that is, let's take the second example. So example 2, we've got 6m squared n times the parenthesis 4m power 3 n squared, then all squared. So we have no issue with the first term there, 6m squared n. However, we've got to open this bracket up. By so doing, we are using the power 2 here outside the bracket. This 2 affects every content of this bracket. So this actually means 4 squared times, this is m cubed, also squared, times n squared, also squared. So this power 2 is affecting every individual term inside the bracket. 4 is having squared. The m cube originally is still here. Then also having its own share of square. And then the n square is having its own share of the same square. So this square goes across the 3 terms. Hence, I'm going to have here 6m squared n times 4 squared is 16. Then, yeah, the other law, then I have m power 3, then power 2 here. So it's going to simply be here 6. This will not be 3 plus 2 because it's a single variable. We are going to multiply the powers here. That should not be confused. So this is 2 times 2 there, 4. So we are now at the basic level whereby you can simply multiply numbers separately. And as we have 16 times 6, which are the coefficients. Then the letters now. m squared, m6, taking the m's first, m squared, m6, then the n, and n4. So 6 times 16, that's 96. Then by the law of indices is applicable basically to same basis. So m, this is 2, 6, that's going to be plus 6 because this is times. Then n. Note, this n is power 1 here, so that's 1 plus 4, making your final answer to be m8 n5. And that is much the solution to that question number 2. If that is clear, as I believe it will be, we look at question number 3. The only thing that is a bit different here is the negative value. So we have minus 2k m squared all cubed times minus 4 bracket minus k squared m cubed all squared. Now, the rule remains the same. We open the bracket with the index outside the bracket. So in this case, I'm going to have minus 2 power 3 k power 3 m squared first, then also power 3. The 3 must go around the 3 terms. You must know that this minus 4 is outside the bracket, so it's not affected by whatever happens inside the bracket. So it's outside. So we're going to have here now, starting with minus k squared power 2 m cube power 2. So we have minus 2 to the power of 3. That means minus 2 times minus 2 times minus 2. That's minus 8. Then k cube m 2 times 3 is 6 times minus 4. Now minus k squared that's going to be plus k power 4 because minus times minus is plus. Then m cube squared, that's m6. So we are done with the expansion of the brackets. The next thing is to multiply the number. So we have minus 8 times minus 4 times k cube times k4 times m6 times m6 again. We have m6 here and also m6 here. So minus 8 by minus 4 is minus 32. Sorry, plus 32. Sorry about that. Because minus times minus is plus. Then k3 times k4 is simply k7 by adding the powers. Then m6 plus 6 m12. And that's the answer to that question as well. And with that, we've come to the end of our lesson today, which has to do with the basics of indices and their rules. So with this, you now understand what exactly it means when we say indices. You understand the concept of coefficients, the concept of variables, and the concept of indices, which, as I said, is the plural of index. And went through the rules of indices, or popularly called the laws of indices. There are a set of rules that govern the operations of indices. And that will be the end of our lesson today, which I hope you enjoy as much as I did. Thank you.